All right, so today I'm going to go over lesson 1-1. There's a lot of stuff in it. A lot of it's review, part of it's not. So I'll kind of go through what I think is review a little quicker than the rest of it. So we're going to look at functions. So one of the things you need to remember, and we've talked about this before, are that x values are your domain, y values are your range. So typically, your domain are the numbers that you put into the formula, and your range are the numbers that come out, typically. Not always, but typically your domain is your input, your range is your output. So then, for example 1, you're going to test for a function. Does anybody remember what the function test is for number 1? Looking at ordered pairs, how do you know if it's a function? The x values. So we always care about, because when we look at, let's just look at the graphs for a minute. When we look at a graph, something is a function if it passes the vertical line test. In other words, if I put a vertical line through the graph and my pencil only touches that graph only once, it's a function. So this left graph is a function because no matter where I put my vertical line, my pencil, it only touches the graph in one place, this parabola. But if I put it over here on the parabola this way, doesn't it touch here and here? Even though here is just one place, anywhere else on that graph, it touches it twice. So this one is not a function. Whereas this one is a function. And you want to use your vertical line test. So the point is that we don't want 2 points to be vertical to each other. If 2 points are vertical to each other, do they have the x in common or the y in common? If 2 points are vertical, so look at this ordered pair here. So let's look at this one and this one. What's the ordered pair for this one? 3, -2, right? What's the ordered pair for this one? What's its ordered pair? 3, 5. What do they have in common? Their x value, right? So since their x value is in common, when you look at question number 1, so let's go back to question 1, we are looking for x values to repeat. If x values repeat, it's not a function. So look at your x. We've got a 4, a 7, and a 3. Do the x values repeat? No. So this is a function. And you might want to add in here, you're looking for x values to repeat if you didn't know that. So add that as an additional note. So we can test for a function given ordered pairs. We can test for a function given graphs. What if you're given an equation? We are specifically looking for no powers other than 1 on your y value, which is your range. So here, notice that the x has a squared, but I'm really only focusing on the y. The y is to the first power. That's what I want. This is going to be a parabola opening up or down. The minute your y is squared, it becomes a parabola opening right or left, as you learned in Algebra 3-4. So because of this right here, this one's no. This one's yes. And then 4, function notation, f of x is exactly the same as y. F of x is a replacement for y, your range. F of x represents your range. And for these right here, they mean the same thing. The second one is in function notation. The first one is not. It's in slope-intercept form. This is still slope-intercept form, but it's just in function notation because instead of y, we have f of x. Any questions on that? Okay. So then let's look at example 2. Now we're going to evaluate some functions. You're going to plug in different domain values to get a range. So here they're giving you the function in function notation. So g of x is equal to, everywhere that you see an x in this equation here, this one is saying to do what with it? Replace every x with a 2. So instead, I've got g of 2 means I'm going to take every x and put substitution parentheses in. So I'm rewriting the original function up here, but instead of x, I'm going to replace it with a 2. So tell me what you get. It's a toughie. What'd you get? 9. So your answer is 9, but you should write your answer as g of 2 is equal to 9. That's the proper way of writing your final answer. So try the second part. This one you're not going to get a nice happy answer, right? So everywhere there's an m, you're going to replace it with something uncomfortable in x plus 2. Be careful when you square x plus 2. You do not get x squared plus 4. So remember that this means x plus 2 times x plus 2. If you FOIL this, you get x squared. You get a 2x here and a 2x here. Adding together, you get a 4x. And then 2 times 2 is 4. So when you square x plus 2, you don't just get x squared plus 4. You're missing your middle term, which is a 4x. Then finally collect any like terms that you can. And so the proper way to write this would be g of x plus 2 is equal to x squared plus 8x plus 9. All right, so then flip to the back of this. So then we're going to look at piecewise functions. So piecewise just means it takes a piece of one graph and a piece of another graph, and they put them together as one whole graph. They may or may not be connected. There can be open circles and closed circles. So what happens is these right here, these are your domain restrictions. Because they're saying something about x. So for x squared plus 1, we're only going to use this function when our x value that we're plugging into it is less than 0. What kind of numbers are less than 0? No, there are real. Negative ones, right? Oh, you're pointing to, oh, that was you. So less than 0 would be negative numbers, right? Does that include 0? What if x is 0? Would I be able to plug it into here? X 0 is not less than 0. But this one says x is greater than or equal to 0. So what kind of numbers are those? 0 and then positive numbers, right? So then you're going to take and evaluate what the function when x is 2 and the function when x is negative 1. So you have two different problems that you're doing. So let's find f of 2. So f of 2, you have to look at your two different equations in your piecewise. Which one are you going to plug it into, the top one or the bottom one? Why the bottom one? Not because it's easier. What's the restrictions? When your x is 2, it matches this restriction here, x is greater than or equal to 0, right? So we're plugging into this one because that's the restriction on x. when x is greater than or equal to 0, you have to use that equation. So we're going to replace x with 2 and subtract 1. So f of 2 is equal to what? 1. If you had plugged it into this one, you would have gotten a different value and you would have been correct. Sometimes you can plug it into both of them and get the same value, but it doesn't happen for very many points. So then you find f of negative 1. Decide which of the two you're going to use and plug it in. So what value did you end up getting? Anything different than 2? Which one did you end up using, the top one or the bottom one? Why the top one? Because it matches the restrictions, right? So then this should have been what your work looked like. Plugged in negative 1, when you square negative 1, it does become positive. It doesn't remain negative. So your answer is not 0, that's why it's 2. So something that's not restricted, and this, by the way, you should probably read f of x down here. It's right here. Something that's not restricted, x can be any real number. So here there's no restrictions, right? Some of you struggled with this in the P chapter, with restrictions. So we're going to go through domain restrictions again. And then you'll see on your test, when I pass it back to you, how well you did. But this hurt a lot of you because it was about a quarter of your test. So something like this has no restrictions because your x is not in a denominator and it's not underneath a radical. Those are typically the things that are going to affect the domain. If there's a radical in the problem or if there's a variable, the x is in the denominator. Because what can the denominator of a fraction not equal? 0. So look at your different restricted forms here. So you've got a fraction. This is just an example where you have your variable in the denominator. That doesn't mean that x can't be 0. What it means is the domain itself, well, I don't even like the way that says. This whole thing can't be 0, right? X could be 0. If x were 0, what's the value of that fraction? What's 0 minus 4? Negative 4, and 1 over negative 4 is not negative 1/4. So x can be 0, correct? But your restriction would end up being x minus 4 cannot be 0. Solve that for x. What do you get? X cannot equal what? 4. You may have to write that in interval notation, and we'll do some of that down below. But this is the true restriction that I'm looking for that particular problem. This is an easy square root because it's just an x under it. But what value can x not be that would create a problem here? Negative. You can't take the square root of a negative number, right? So only the x, not the square root, but only the x, whatever's underneath here, has to be greater than, could it be equal to 0? Could I take the square root of 0? Yeah. So it's greater than or equal to 0. And there's no solving in here. That is the restrictions. X is greater than or equal to 0. And so that's what I put down here for you. It must be greater than or equal to 0. But you only take what's underneath the square root. Don't include the square root when you're doing the restriction for that. Some of you tried to include the square root and it messed you up. And in a real life problem, you might only want positive numbers. For instance, if I'm finding the distance of something, is distance ever negative? No. If distance is negative, then all you see are soles of feet with people walking upside down, and you don't see their body. Have you ever seen that before? I guess it could be termed a ghost, but that just means the person's not there. So that's not a reality. So there's a real life situation of where you might want to restrict the domain. So let's look at these. We are finding the domain of the following. So we just have a list of ordered pairs. What's your domain going to be? Yeah, the domains are all the x values. You're just going to list the x values, and you don't list them more than once. So if the x happens to repeat, don't relist it. You could order them from smallest to largest. That's fine. You don't have to. I don't care. You can order them exactly the order that they come. That doesn't make any difference. Not to me anyway. What would be the domain here? What values could x be? There's no equal sign, right? So what values can you put for x? Anything? Or is it restricted? It's unrestricted, right? So your answer to this would be your domain is equal to, instead of saying unrestricted, oh, there's my braces issue. I can't make those, remember? All real numbers. So that is a no restriction, and that's how you would write the answer to that domain. Now we have a fraction with a variable in the denominator. Is that something that should be restricted? Yes. So how are you going to restrict that? Okay, you're going to set that whole x minus 8. We just want to make sure that that value, that expression, doesn't equal 0. So what is it that x can equal? X can equal 8. The best way to probably show that, and it just depends on what the directions ask you for. If they don't give any indication as to how you have to answer the question, you can leave this as your answer. But if they say use interval notation, x can be any value but 8. So on a number line, you've got negative infinity going up to 8, but you don't include 8, and then going past 8 to the right to positive infinity. So you really only have one boundary point. So your domain here would look like this. You would have negative infinity. Oops, I wrote it so it looks like a negative 8. I'm going to fix that because that really bothers me. I have infinity issues too. Alright, so let's try that again. So negative infinity to what's my boundary point? What am I going to butt up against? 8. Does my solution set include 8? Yes or no? Does not include 8, right? So I want to put parentheses here because I'm going from negative infinity all the way up to 8, but not including 8, right, on the left side. I don't want to include 8, so I'm going to union it. My left boundary now is going to be 8 again, but I don't want to include it. And I want to go to all numbers greater than 8, so positive infinity on the right. So that's what your interval notation would look like for that. Is this restricted? Yes. To what? Speak up a lot. Greater than or equal to 0, right? So only the part that's underneath the radical, not including the radical. So that can be greater than or equal to 0. So then solve for that. So if I divide by 2, don't I get 1? So x can be any value greater than or equal to 1. Again, if the directions don't say that you have to use interval notation, then you can have that as your answer. But if it were interval notation, we have nothing that's to the left of 1, correct? Do we include 1? Yes. So 1 is my left-hand boundary. So I have a bracket at 1. And then I want to go greater than that, so I do positive infinity. No union needed because I'm not doing any numbers to the left of 1. I don't need any of those. Now, there was one thing on your test that you had, what if I took this radical and put it under 1, so I had 1 over that radical? How does that affect my restriction? The minute the radical's in the denominator, can it have a value of 0? Yes or no? No. So the only thing that would change is this would read greater than 0. The answer would still be the same, and you would end up with x is greater than 1, so you would end up with a parentheses here at 1, if this were 1 over the square root of 2x minus 2. So there's a slight difference where you're putting both of these restrictions together in one problem. All right, then here, we want to find our restrictions on L, on W, and on H. This is a volume problem. What do you know about length, width, and height of anything? What do you think? It has to be positive. Can it be 0? No. If you have a length that's 0, are you going to have any volume to it? It's missing a dimension. So if it's missing a dimension, it's not three-dimensional. It has no volume. You can't actually pick it up and touch it. So our restrictions here would look like this. The domain would equal, and you're going to take L, comma W, comma H, has to be greater than 0. So you're telling the reader that all three of those have to be greater than 0. Good with those. Okay, so you practice that tonight. Then last page. Sample 5's a smidge tricky. We're making a new soft drink can that is a little narrower and taller than the regular can. What kind of drinks come in a narrower, taller can in your day and age? Energy drinks, right? So let's say that we're making one. We know that the ratio of the height to the radius is, so this is important, the ratio of the height to the radius is 4. And then here's the volume formula itself. And so the ratio of the height to the radius is 4, actually has been given to you right here. H over R is equal to 4. That's a ratio of height over radius. Whichever comes first comes in the numerator. So if they hadn't written that out for you in the problem, you would know how to write it yourself. So that's going to be important. And then the volume formula is going to be important as well. The first question says, write the volume as a function of the radius. In other words, I only want to see R in the volume formula. What's there that I don't want to see? Height, H. So we've got to remove H and replace it with something in terms of R. Don't we know that height, well, the ratio of height to R is 4. Can I use this? What do I want to solve it for if I want to get rid of H? And replace it with something in terms of R. So I'm going to solve this for which one? Whichever one I want to get rid of. So if I want to get rid of H up here because I want the function to be in terms of the radius, I'm going to solve for H. So I'm going to take this, I'm going to solve it for H. So I have H over R is equal to 4. Because I want to get H equals on one side, because then I can take what H equals and replace it back into the volume formula with that amount. So how do I solve for H if it's being divided by R? Multiply both sides by R. And so I end up with H equaling 4R, correct? So I haven't rewritten the volume formula yet, but can't I replace H with 4R? So I'm going to take volume equals pi R squared, because that's okay, but I want to replace the H with my new value for H, which is 4R. Normally we wouldn't write a formula like that. We would want the 4 in the front of the pi, and we want to multiply the R squared and the R together. So our final volume formula would be 4 pi, and then R squared times R is what? R cubed. So this would be our final volume formula as a function of the radius. So I want you to write the volume as a function of the height. So you're going to do the same exact thing as we just did, but this time here, instead of solving for H, what are you going to solve for? R. So you're going to solve for R. Now let me give you just a little hint. When you have H over R equals 4, in this particular case, if I were you, I would change this to 4 over 1 because don't you have a proportion here? How do you solve proportions? Cross multiply. So you'll cross multiply. It's not going to solve for r yet, but it's a lot easier than what some of you are going to try to do. So you go ahead and solve for r, and I'll slowly do it up here. And if she's too loud, you can close that door. Sometimes it's hard to hear. So h is a little bit more difficult, only because you're dealing with a fraction. So your value for r should have turned out to be h over 4. So in the original formula right here, I'm replacing the r this time, which has to be squared. So my r happens to be h over 4. When I square that, I end up with h squared over 16. These two didn't change. You can take that 16, which is in a denominator, and you can pull it out as a coefficient. Wouldn't that be 1 over 16? You could do that. The pi is in the numerator, and then the h squared times h is h cubed. Or you could say, oh, all of those are in the numerator. So if you multiply them together, you get pi h cubed or h cubed pi. It doesn't matter which. And then the 16 is the part that's in the denominator. Either one is acceptable. They're both fine. So that was new, probably, right? Okay. Example 6 is most likely new to you as well. I don't think you did a difference quotient in Algebra 3-4. Is that correct? You're not going to like it until you get used to doing it. This is going to come back, question 6 is going to come back to haunt you over and over and over again. You have to know how to do it. It's how we do derivatives. So it's a shorthand. If you don't learn how to do this, it's going to hit you again and again and again this year. So you've got to figure out how to do it. It's just a pattern. And part of it is you get hung up on, you think it's complicated, and it really isn't, if you think about it. So we're going to evaluate what's called a difference quotient. Later, we're going to use it to solve derivatives. Derivatives are an opening into calculus. That's why we're called pre-calculus. All right, so here we've got this function of x, which is negative 2x plus 4. Then you are to find what's this part right here is called the difference quotient. You're to take the function of x plus h. So what am I asking you to do? The function is f over here. What am I asking you to do with x plus h? Replace that x with what? X plus h. If I said f of 2, wouldn't you replace that x with 2? So you're going to do nothing different than write the function how it would look if x were x plus h. So I'll show you what that looks like in a minute. Then you're going to subtract the function of x. Isn't this the function of x? Okay, so we'll subtract that, and then it's divided by h. H cannot equal 0. Does that make sense to you? Why h cannot be 0? Because it's in the denominator. All right, so let's go ahead and see what this looks like. So we're going to take f of x plus h. I'm going to take this f function right here, which is negative 2. Anywhere there's an x, I'm going to put parentheses. And anywhere that there's an x, I'm telling you for this part only, you're going to replace each of the x with x plus h. Because that's what they told you to do. So this is the function of f, with x replaced with x plus h. Does that make sense? Because I'm going to go slowly. Then I have to subtract the function of x. So then we are going to subtract, and if I were you, I would use brackets in here. You're going to subtract the function of x. This is the function of x. Negative 2x plus 4. This is the function of x. It's going directly to there. So this right here is f of x plus h. This is minus f of x. And then it's all over what? H. Now all that's left once you get that part is to do the math. So here we go. I'm going to distribute my negative 2. So I get negative 2x minus 2h plus the 4. Then the reason why you have to use brackets here is if I'm going to subtract that whole function, I have to subtract everything, which means don't I change all the signs in here? Because I really have a negative in front. I'm going to distribute that negative into the brackets, and a negative times a negative is a positive 2x, and a negative times a positive is a negative 4, all over h. Your h is eventually going to cancel out, so if you're left with a problem where you still have a fraction, most likely something's wrong, unless it's just a quirky problem, but most likely something would be wrong. So then keep going. I've got, oftentimes things are going to cancel out up here. Doesn't my 2x and my negative 2x and my positive 2x cancel out? And doesn't my positive 4 and my negative 4 cancel out? Try to combine like terms. What's left in the numerator? Negative 2h over h. Do you see how my h is going to cancel out? So my difference quotient turns out to be negative 2. So this whole value is equal to negative 2. Oftentimes you're still going to have an x in your answer. This one just turned out to be a real number. Okay, so we got another one we're going to try. This one's a little bit more complicated. Yes.
Is the difference quotient always the same?
Typically, yes. They might change a few things on it because of the section that you're currently in. When we use it for derivatives, it'll stay the same. But like they might do f of 2 here. Or they might do x plus 4 here. It just depends. You'll get some different problems in there. But for the most part, it's that form. Okay? So we're going to take this 2 different times. So the first time, we're just going to replace every x here, and aren't there 2 places to replace the x with x plus h? You need a lot of room to do your difference quotient. So I'm going to rewrite this. I'm totally ignoring that part right now. I'm just rewriting that part with every x as x plus h. So squared minus 4 plus 7. So in each of the x's goes x plus h. You have to be really careful that you remember how to square this, but we'll get to that in a minute. Because we talked about this earlier in the lesson. So this is f of x plus h. Then we have to subtract f of x. Since this is f of x, I'm not changing it. I'm going to subtract that whole thing. So I've used brackets, x squared minus 4x plus 7, and those brackets, all over h. Move that up. Here's where you have to be careful. So again, let me just start back again. This is my f of x plus h. This is my minus f of x, and it's over h. You have to square this correctly. It is not x squared plus h squared. It has a middle term, right? This is x plus h times x plus h. You're going to get really good at squaring a binomial. So what does that give you? X squared, what's your middle term? 2xh, because you've got an xh here and an xh there, here an x there, an x there, an x there. Come on, your 7th period. Even Geico has Old McDonald's on it now. So plus 2xh, and then what's your last term? H squared. So that's just x plus h squared. That's the hard part, don't mess it up. Then distribute your negative 4. Whoops. and then plus 7. Well, I'm going to have to squeeze in the last part here. Then I have to distribute this negative and basically change every sign in here. So I end up with minus x squared plus 4x and minus 7 all over h. And then a bunch of stuff should start to cancel out. What can you cancel out? Your x squareds cancel. What else? The 4x's cancel. What else? And the 7's cancel. You'll notice that everything else left has an h in it. So write what's left. And it really doesn't matter what order, so I'm going to move it over here. So I have a 2xh. I have a plus h squared. And I have a minus 4h all over h. Do you agree that that's all I have left? Don't just cancel vicariously. Look at the numerator. What's the greatest common factor? In h. So we are factoring an h out of the numerator. I'm left with a 2x here, a plus h here, and a minus 4 here, all over h. Now do you see that the h is canceled? If your h in the denominator doesn't cancel, you probably did something wrong. So you've got 2x plus h minus 4. It doesn't matter what order. And it doesn't matter that you have an h left in your answer. That's fine, as long as there's not an h in the denominator. So this is an exercise in manipulation. You have to learn to get good at this because we use this to, trust me, if you do derivatives the long way, this is a great shortcut. Well, this is actually doing derivatives the long way. There's another shortcut on top of that. But you need to understand how derivatives are found before I show you the shortcut. All right, any other questions? All right.